Hello, Yunan. Today's lesson is going to be on index laws. And I'm calling this part 1 because we're going to spend probably most of this week looking at different index laws. What we're specifically looking at today, though, is multiplying and dividing indices, or terms that have indices, I should say. Let's quickly recap what we were doing on Friday, looking at index notation and expanded notation and how to convert between the two. So what I'd love for you guys to do right now is pause this video, write down these two questions in your book and come up with an answer for yourself. And when you start the video in a second, I will show you what my answers are. Okay, so hopefully you've had a go yourself. 6 to the power of 8 in index notation is the same as 6 times by itself 8 times. And moving on to the second one, we have 4 times by itself, and we just have to count up how many times. 1, 2, 3, 4, 5, 6, 7. Sorry, 8. There's 8 there. So in this case, to turn this into index form, our base is 4 and our power is 8. Alright, moving on to new content for today. What I'd love for you guys to write down is this line here and this line here. We'll be doing some examples in a second. What we're looking at here, though, is we have a term with a power, a to the power of m, times a to a different power, a to the power of n. What happens when we do this multiplication? Well, we can actually simplify this into a to the power of m plus n. We take the two indices here and we add them together when the base is the same. This is important though. This can only happen when the base is the same. We have an a here and we have an a here and an a here. Now, when we move on to division, a to the power of m, a to the power of n, we actually subtract instead of add. And something important I want you to note here is that every time I want you to answer one of these questions, I want you to, if it's written like this, with a divide symbol, I want you to change it into this form. Write it with a fraction, and it will be much easier to not make the mistake of, instead of writing m minus n, you might write n minus m. If you put it into this form, it's very easy to recognize that it's the top number minus the bottom number. Let's put this into practice though and see how it works practically. What I'm going to do is I'm going to show you how to answer A and C, and then I would like you to pause the video and have a go at B and D yourself. So in part A, we have 3 to the power of 6 times 3 to the power of 4. Now we have the same base, so I can rewrite this to 3 to the power of 6 plus, that should be a 4. So the answer is simply 3 to the power of 10. Now, pause the video, have a go at part B for yourself. Okay, hopefully you've attempted this question yourself. The important thing we need to note here is that we don't write an indice on the second 4, but we need to recognize that there should be a 1 there. So when we combine our indices, it's actually 5 plus 1. The answer is 4 to the power of 6. Alright, now some division examples. 7 to the power of 9 divided by 7 to the power of 5. Remember, our first step should always be writing it as a fraction, and now we just have to remember 9 minus 5. So our answer is going to be 7 to the 4. And again, I'll get you to pause the video, have a go at this question yourself. Remembering that we have a 1 here. So we're going to write it in a fraction. And then that makes it easier for us to recognize that it's 8 minus 1. Or 6 to the power of 7. So this works the same when you have non-numerical bases and some slightly more complex terms in our multiplication. Let's have a look at part A here. Ooh, sorry. So this is exactly like the examples we just saw. We simply add up all the indices, and our final answer will be x to the power of 11. Now, when it gets a little bit more complicated looking like this, it really doesn't make the question any more complicated. Sorry, that's a 2. We just look at the terms with the same base and add the indices together. So this becomes x to the power of 5 and also y to the power of 5. And it works the same when we have a combination of multiplication and division. In these cases, however, it's almost even more important for you to write the divisions as fractions. Now, I think the best way to approach answering this question is to just deal with the top first. Forget about what's down here. For now, we're not interested. Just deal with the top. X to the power of 2 plus 3. So then it becomes x to the power of 5 over x to the power of 4. And then we proceed as before and turn this into x to the power of 5 minus 4. And there we have our final answer. Now, this looks a lot more complicated than what we've seen so far, but really the process that we go through to answer this part is exactly the same. First thing we're going to do is just forget about the bottom and deal with the top. We're going to deal with the numbers first. 2 times 8 is 16. Then we're going to deal with the A's, add the indices, and we're going to deal with the B's, add the indices. So when we simplify this, it becomes a to the power of 5 and b to the power of 4. Now we deal with our division, remembering top number minus bottom number, top number minus bottom number. When it comes to the numbers over here, we can simply divide 16 by 4. A to the power of 5 minus 4. And b to the power of 4 minus 2. And we end up with an answer of 4 times a to the power of 1 times b to the power of 2. So you guys are going to go to your textbooks now, page 342, start working on exercise 7b from question 5, but again, you only need to do the left-hand column of questions because each question has quite a few parts. Thanks, guys.